Alright, so the next problem that we need to do is rewrite the following in vertex form, and we need to find the vertex and the axis of symmetry. So luckily for us, we don't have to factor this mess. It would be kind of gross, and that's okay. So trying to find the vertex, I'm going to show you the easiest way possible. So the first thing that I'm going to do is I'm going to try to find the x-coordinate of my vertex, because my vertex is just some point, which this parabola is going to go from going down to going up, or vice versa, from going up to going down. Alright, so in this case, I would rewrite this as f of x is equal to negative 3x squared plus 6x minus 5, just rewriting that in standard form. So I've got a parabola this time. Sorry, I already spoiled it a little bit. That is going down. How I already know that is because my a in this case is negative. So because it's negative, we're thinking negative thoughts. We normally frown. So it would be an upside down parabola, which looks surprisingly like a frowny face. So how I'm going to find my x-coordinate of my vertex is I'm actually going to use part of the quadratic formula, which is going to just be that negative b over 2a. So in this case, my b, since I've rewritten it in standard form, is just going to be that number out in front of your plain old x, which is 6. So I've got negative from my formula, 6 from my original equation, all over 2 times a. Well, a is going to be that number out in front of my x squared, which is negative 3. So all in all, my x-coordinate should be negative 6 over negative 6, which is going to simplify down to a positive 1. So there's my x-coordinate of my vertex. Well, that's nice, but how the heck am I going to find the rest of my vertex? Because I said it was a point. Well, a point has an x and a y. So all that I'm going to do in order to find my y-coordinate is I'm going to go ahead and I'm going to plug this x value in. So again, this f of x tells me I have a function of x. This time my x is 1. So plugging 1 in, I should have f now of 1, saying, hey, I am plugging 1 into x using that function notation. Is going to be equal to negative 3 times x, which is 1 this time, squared, plus 6 times x, which is 1 this time still, minus 5. And now all I'm going to do is simplify that right-hand side and leave that left-hand side alone, because this is, on the left side is something called function notation. We don't touch the left side. We leave it alone. We keep rewriting it like that. It is not f times 1. If you haven't noticed, I keep saying f of 1. Alright, so let's go and simplify this. I get negative 3 times 1, because 1 times 1 is just still 1, plus 6 times 1 is just 6, minus 5. Simplifying this again, I get negative 3 plus 6 minus 5. And simplifying that down, I get negative 3 plus 6, which should be negative or positive 3, minus 5. And then so finally I should get negative 2. So all in all, my vertex should be, I plugged in 1 and I got negative 2. So my point in this case would be 1 comma negative 2. Alright, that's nice, because mostly the hard stuff is done. So now I've got to rewrite this in something called vertex form, which is up here. So what are all of these lovely letters? Well, A is just going to be the same A from standard form. X is going to remain an X, and only an X, until I plug something in for X to try to find another point. My H is actually going to be my x-coordinate of my vertex, and my K is going to be my y-coordinate of my vertex. So looking at this, my vertex form is y is equal to a times x minus h quantity squared plus k. So I've got y is equal to a. Well, my a in standard form was negative 3, so guess what? In vertex form, it's also going to be negative 3 times x minus h. Well, h is my x-coordinate of my vertex, which is positive 1. squared plus k. Well, k in this case is -2, so I plug that in. And because we are not in Algebra 1 anymore, I am not going to leave this plus negative in my final answer. That's gross. Miss Schuessler does not want to see that. We clean that up. So I get y is equal to -3 times the quantity of x minus 1, quantity squared, now just -2. And that's cool. Alright, so found my vertex form. That's the hard part. I found my vertex. Now I just need to find my axis of symmetry. Well, the really cool thing is I've actually already found my axis of symmetry, because my axis of symmetry is always going to be an x equals line. And guess what? We've already done the hard stuff. In order to find your axis of symmetry, it is actually going to be this mess of x is equal to -b all over 2a, which in this case we found was 1. So my axis of symmetry, which I normally represent with AOS, is just x is equal to 1. And there should be no surprise that your axis of symmetry's x should also match your vertex's x coordinate. Your vertex should lie on your axis of symmetry when it comes to parabolas and absolute values. Alright, on B, same thing. We still need to rewrite this in vertex form, find the vertex and the axis of symmetry. So this time it's already in standard form where I've got ax squared plus bx plus c, which now I can just try to find my axis of symmetry and my x coordinate of my vertex. How I'm going to do that, again, is that x is equal to -b all over 2a, which is going to be equal to -b, which is 12 this time, all over 2 times a, which is 3. So then I get -12 over 6. -12 divided by 6 should be -2. So my axis of symmetry should be equal to x is equal to -2. Alright, that's cool. Well, now I can use this x coordinate and I can go into my original standard form and plug this in for x. So I should get f of -2 should be equal to 3 times the quantity of -2 squared plus 12 times -2 plus 11. That should be equal to f of -2 is equal to 2 squared, because we always deal with the exponents first, should be a +4, plus 12 times -2 should be -24, plus 11. So then I get f of -2 is equal to 3 times 4 gives me 12. This plus negative turns into just -24 plus 11. So then I get f of -2 is equal to -12 plus 11, because when I have just addition and subtraction, I do both of them at the same time, working in order from left to right, because again, PEMDAS is always parentheses, exponents, multiplication and division at the same time. You work that from left to right. And addition, subtraction, again at the same time. You work that from left to right. Once that's all you have left. So multiplication and division, addition, subtraction. Multiplication and division are weighed the same. You do those at the exact same time. Addition and subtraction are weighed the same. You do those at the exact same time. I get so tired of seeing people on Facebook having fights about that stuff. Oh my goodness. Anyway, back to actual, pre-calc. So then I get f of -2 is equal to now just -1. Alright, so I've got my vertex, I've got my axis of symmetry. All that's left is rewriting this in vertex form, which again, that vertex form is y is equal to a times x minus h, quantity squared, plus k. So again, my a is going to match my a from standard form, which in this case is 3. My x stays an x unless I'm actually plugging something in to try to find another point. My h is my x coordinate of my vertex, and my k is my y coordinate of my vertex. Alright, so my vertex was just, I plugged in -2, I got -1. So now I can go and plug that in. So then I get y is equal to 3 times x minus h, which in this case is -2, quantity squared, plus k, which is -1. Simplifying this, because Miss Schuessler does not like double negatives or double signs anywhere, so I get y is equal to 3 times x now plus 2 squared minus 1, and we're done.